If there is a difference of potential between 2 points in space, and if you connect a conductor between them, then charges will flow from one to the other. Normally, this difference of potential is a battery would maintain some kind of difference of potential or voltage across its plates. And the charges that flow normally are in fact negative charges that go from the negative part to the positive part. But in the standard definition of current, we assume that there are positive charges that flow, even though we know it is not positive charges. But the direction of current is the direction of flow of the positive charges. And if the charges go through some device in here, like a bulb, then they lose energy and, in fact, heat up the light bulb in this case, or heat up the resistor, and produce light. Current is defined as the rate at which energy flows. The rate being how many coulombs per second is flowing. So, for example, if there are 10 coulombs of charge flowing in 2 seconds, that means the current is 5 coulombs per second, and a coulomb per second we define as an amp. 1 amp is 5 coulombs. 1 amp is a coulomb per second. So, for example, this problem, supposing 20 coulombs pass through a filament bulb in 2 seconds, find the current and the number of electrons. So the current is how many coulombs per second. So the current would be 20 coulombs in 2 seconds. This is 10 coulombs per second, or 10 amps. Another part of this, find the current and the number of electrons. So each coulomb represents a certain number of electrons. So the charge of 1 electron is 1.6 times 10 to the minus 19 coulombs. So for 20 coulombs, you would need N is equal to 20 divided by 1.6 times 10 to the minus 19. This turns out to be 12.5 times 10 to the 19th plus 19 electrons. Now, the resistance of the conductor that is connected between the 2 points, there is a resistance there to flow of electricity. That resistance depends on a couple of things: what the conductor is made of. Basically, the conductor very often may be just a piece of wire. So it depends on what kind of wire that is. Is it copper or is it something else? It depends on the length of the wire and the area or thickness of the wire. So if you make the length longer, the resistance is larger also. If you make the area bigger, so this is a larger area than over here, then you make the resistance smaller because it's easier for the current to get through. As an example of calculating this, supposing we have a lamp cord which is 0.75 meters long, made out of copper wire. What is the copper wire's resistance? So we're going to use this equation here to calculate that. And of course, to do that, we need to know the resistivity of copper wire, which is right here. So the resistance is going to equal to rho, which is 1.7 times 10 to the 18 ohm meters, multiplied by the length of the wire, which is 0.75 meters, divided by the area between the plates. Since this wire is 1.15 millimeters, the area is going to be pi r squared. We have to change the radius to meters. And if we do all that, this is what we get. Let me make this a little bit better here by erasing the material I put on here. .0018 meters. If we want to calculate the current that actually flows not through a wire, that was the only resistor. But let's say there is another resistor, say 1 meter long wire is connected to a 12-volt battery, 20 coulombs of charge flow through it in 10 seconds. What is the resistance of the wire? You can use Ohm's law to calculate that the resistance of the wire is the voltage divided by the current. A 12-volt battery divided by the current, which is 2 amps, right? It's 20 coulombs, flows in 10 seconds. So the current is Q over T is equal to 20 divided by 10 is equal to 2 amps, 2 coulombs per second, or an amp. So 12 volts divided by 2 amps equals 6 ohms. That's the resistance of the wire.